Hi there, learners! I hope you're all good and ready to learn something new today. Before we begin, make sure you are in a comfortable place, your materials are ready, and your mind is focused. Today, we're going to explore what happens beneath the Earth's surface and understand how geological are formed. Are you ready? Let's begin our journey into the moving Earth. Our topic for today is all about earthquakes and faults. Did you know that the Philippines is located along the Ring of Fire? The Philippines is located somewhere here. This is not the actual location, but this is just for our presentation purposes. The Ring of Fire refers to the region around the Pacific Ocean that is commonly hit by the earthquakes and volcanic eruptions. An earthquake is one of the most horrifying phenomena that anyone can never experience. We first thought that there are these rocks solid and steady. However, you may have experienced that the ground shake, and this contradicts to what humans believed before. Earthquakes can cause destructions all over the world even in the past. People have started recording these events. No wonder scientists have been working very hard to find ways to predict when the earthquakes occurs. We can't stop this natural event from occurring. However, we can learn all about earthquakes and prepare for it. Earthquakes are associated with faults. When a fault suddenly moves, an earthquake occurs. A fault is a break in the Earth's crust, and along the break, significant movement has taken place. The word break refers to crack on the ground, while crust refers to the outermost layer of the Earth. We live on the surface of the crust, and significant movements means that the rocks have been displaced or shifted considerably. Before we dig into our topic, let's do some first an activity. Let's go! In this activity, first, prepare sand in a container. Arrange 2 sheets of cardboard edge to edge. Second, pour sand along the boundary of 2 sheets. Third, with a roller, flatten the top of the sand and make 2 parallel lines. Now, move the cardboard slowly in the direction as shown. What have you noticed? What is forming the sand? What happened to the line? If you did the activity right, you may have seen something like this. A crack forms in the sand and the parallel lines become displaced, simulating how rock masses shift along the fault. Look at this image here. Did you find any similarities to the activity done earlier? Based on the activity and the picture, you can probably guess where the fault is by now. A fault is a play factor or discontinuity in a volume of rocks across which there has been significant displacement as the result of rock mass movements. Now, how do faults produce earthquakes? To answer these questions, let's do another activity. In this activity, first, prepare 2 boxes of the same side by side. Second, prepare a paper clip with a rubber band attached to it. Put 2 holes in one box and attach the paper clip as shown. Put a tape between the 2 boxes and tie a house on top of the box with a paper clip. Lastly, pull the rubber band with one hand and use your other hand to stabilize the box. If you did the activity right, you would have the same results in the rightmost picture. The boxes represents the ground and the boundary between them represents the fault. Energy from the inside the earth makes the ground move. Simulated this by pulling on the rubber band, there is movement right away because of the friction. Once friction is overcome, the ground suddenly moves and earthquakes occur. Some scientists call this process as stick and slip. But where does the earthquake start? Let's do one more activity to find out. In this activity, first, pile the empty boxes one on top of the other in group of 3. Place one pile near one end of the table and the other pile at the other end. Using a stone, strike one pile under the table. Observe the movement of the boxes in each pile. Repeat using the 2 other stones one at a time. Observe the movement of the boxes as soon as you strike the pile of the stone. In this activity, the stone is what we call the focus. The portion of the table directly above where the stone was struck is the epicenter. The table is the Earth's crust. The different sizes of the stones are the different magnitudes. Lastly, how strong or how weak the wobbling was is the intensity. Earthquakes are vibrations or tremors produced within the Earth's outer layers or crust. An earthquake is tectonic. It occurs when parts of the Earth's crust breaks and the rocks together with the fault slides near each other or far away from each other. This is called faulting. An earthquake can also be volcanic. This is caused by the movement of magma beneath the surface of the Earth. The movement results in pressure changes where the rocks around the magma has experienced stress. At some point, this stress can cause a rock to break or move. There are 2 major scales in which earthquakes are measured: magnitude and intensity. Magnitude is the entire energy released by an earthquake at its focus. Earthquakes of larger magnitude are stronger and typically more destructive than those smaller magnitude. Earthquake magnitude is measured using the Richter scale. The intensity of an earthquake is measured in terms of its theological effects of the general damage it brings or the intensity of shaking. An earthquake intensity becomes weaker when it is away from the epicenter. This Philippines Institute of Volcanology and Seismology, or PHEVOX for short, use the following scale to describe the intensity of earthquake in the Philippines. The measurement of intensity and magnitudes are always corresponding to each other. Again, when we say magnitude, it is the energy released by an earthquake of the focus. It is calculated from earthquakes. On the other hand, intensity is the strength of an earthquake perceived and felt by people in certain locality. Intensity is generally higher near the epicenter. The main component of a fault are the fault plane, the hanging wall, and the foot wall. The fault plane is where the action is. It is a flat surface that may be vertical or sloping. When the fault plane is sloping, acts with normal and reverse fault, the upper side is the hanging wall and the lower side is the foot wall. When the fault plane is vertical, there is no hanging wall or foot wall. There are 3 main types of faults. First, the normal fault. Normal faults form when the hanging wall drops down. The forces that create normal faults are pulling the sides apart or extensional. Reverse fault form when the hanging wall moves up. The forces creating reverse fault are compressional or pushing the sides together. And the last is the strike-slip fault. Have faults more sideways, not up or down. Since we cannot predict when the earthquakes will occur, let's talk about some safety measures we need to do before, during, and after earthquake. First, prepare your emergency kits. Second, know your emergency route ahead. Make sure it is safe to pass through and no chances of getting hit by a falling debris. Next, Secure heavy or potentially dangerous objects that could fall on you. And lastly, prepare your fire extinguishing equipment in case of fire breaks out. During an earthquake, move away from windows, glass, and heavy objects. Extinguish any fire immediately. Ensure exit doors are open so you don't get stuck. If you are in bed, stay where you are and put a pillow over your head. Drop down to your knees. Take cover. Get under sturdy table. Hold one of the table legs. Wait until the shaking stops. Then get out of the building as soon as possible. After an earthquake, grab your emergency kits. Never use an elevator. You may be stuck inside if there will be power failures. Next, stay away from damaged buildings. Aftershocks may further damage the buildings, which may lead to collapse. In case of aftershocks, follow the same safety steps of drop, cover, and hold. Lastly, do not go home unless local authorities deem it safe. And let's harvest the fruit of your knowledge to know that you fully understand our topic for today.